F Sharp is the first programming language and functional language that runs on .NET. As a C Sharp developer, I am curious and eager to know more about this topic. So let's learn from Odi, who has spent 2 decades in the tech space. Hi, Odi, welcome.
Hello, Aisha. How are you doing?
I'm doing great. How is the weather over there?
Well, very cold. Canada cold, which is on a different grade from cold, but
Okay.
all well and good. Yeah, it's much better now. Let's put it that way.
All right. Why F Sharp?
Yes, thank you very much. So F Sharp is a functional programming language, like you said.
Okay.
I think to understand the history of F Sharp, you have to understand the history of functional programming.
Okay.
Functional programming came out just around the time the imperative programming came out as well. The first functional programming language was Lisp. It came out just immediately after Fortran. So if you look at the history of imperative languages, you have Fortran, you have C, then C++, before C Sharp, etc. But in the functional paradigm, it started with Lisp, and then you had standard ML or CAML, and then you have F Sharp.
Okay.
So F Sharp, different branch of programming languages.
Okay.
Now, in the past, right, when we started programming, we were programming against in-memory data structures, using a lot of mutation, like updating variables and things like that, with while loops, for loops, etc. Because all the data we needed to do the computation was on memory, right? So whether you are building a desktop app or you're building something, most of the time what you're doing is creating variables, modifying them, writing them back to disk. With imperative languages, you are essentially writing to memory, making modifications in memory, writing to disk, etc., right? Okay. And this was good for applications that we were building at the time. So calculators, desktop apps, things like that. But as you know, the world has evolved into distributed systems where we have servers in multiple places, all communicating with each other. Memory is not static. It's jumping from, is moving from platform to platform, from computer to computer, etc. Okay. And because of this, the entire industry is moving towards a functional style. So, for example, you look at what is going on in Java, in C Sharp, you see that many of the new features that are added to the language are carrying over the functional style of programming. Okay. For example, Rust, which is also which is also gaining in popularity, is highly functional as well. All right. Right. So functional programming has some tenets that are built into it. So one of it is immutability, right? Concurrency. So immutability is the fact that values do not change as the program is running. Okay. This has subtle advantages. For example, if the values don't change, then you don't need to debug them, right? Because you don't need to, because if you think about what a debugger does, a debugger allows you to track how state changes through your program, all right? All right. So when you put a breakpoint, you step through, you step over.
Step into.
What you're doing is you're trying to figure out, okay, this was this value, what's the value at this point, what's the value at this point? So functional programming is trying to eliminate that so that you don't even need a debugger, right? Okay. And you do that using something called immutability, that like I described earlier. Right. Okay. The second thing to remember about functional programming is treating functions as value. Okay. So values here are things that, again, don't change as part of your program, and you can anywhere you can pass an int. For example, you can pass a function that returns an int. Okay. And they are like sort of functionally equivalent, right? So these are some of the tenets of functional programming. There's a lot to go into, but I don't want to.
Yeah, just the fundamentals. The basics.
Yes.
Exactly. Okay. Yes. So if someone who is starting out, when you want to start as a developer, or you want to come into programming, one can be very confused, like, what am I supposed to learn? What language is best for me? So if you are to advise a beginner, like, okay, why not do F Sharp? What are the simple terms you are going to explain to those person that will convince the person from say, okay, let me just go for F Sharp,
Well, I think it all depends on your skill level. Okay. Honestly, anybody can learn F Sharp.
Okay.
The issue there is you have functional languages aren't as popular as mainstream languages.
Okay.
I always tell people, right, if you want to start learning to program, use one of the mainstream languages to learn. Okay, so you learn your Python, you learn your C sharp. Even C sharp is not that mainstream. You can learn your JavaScript just to get a hang of, okay, this is how programs are written. This is how I do a simple web app and things like that.
Okay.
Once you've learned that, once you're no longer a beginner, right, then you should learn a language like F sharp. And the reason why you should learn F sharp is because, again, like I mentioned earlier, that is the direction in which the entire industry is moving. If you look at all the past new functionality added to C sharp in the past 10 years, most of these are things that they took from F sharp. Okay. And yes, and also writing in that functional style helps you to write clear program, right? So when you're writing your programs, you are very sensitive to state. Those are some of the things it teaches you, and it's very, very powerful. Okay. So even JavaScript, for example, is also functional-ish sort of, but you can write JavaScript in a functional style, and it is more readable, right? So it's what separates the senior developers from the like mid-level engineers, is that if a senior developer writes a piece of code and you look at it, you can tell that, okay, this person paid attention to the use of state, how they split their functions, how they are passing functions, and the patterns they use. These patterns are like functional patterns. Does that make sense?
Yeah, it does. So, okay, if I may ask, since you've already mentioned like most of the difference between F sharp and other languages, but can you just give like a key difference between F sharp, C sharp, or Python, Java, and other languages?
Yes. So the key difference here is that F sharp, like I said, it came from a different brand. So what I will, ask people to think about is because it's not familiar does not mean it's difficult, right? People are used to things that they are familiar with, but a language like F sharp is not familiar. But if you become familiar with it, you find out that it's actually a very easy language. So for example, in F sharp, everything is an expression. There are no statements in F sharp, right? So everything evaluates to something, okay? That's one very simple example. Why is this important? It means that you can essentially take segments of your application and run them independently, evaluate their expressions independently of the rest of your app. And you can, mix and match things, because everything is an expression and it flows like an expression. Okay. Secondly, F sharp has a duality involved. So when you're comparing to something like C sharp, F sharp can be written in a scripting like language like Python. So it's closer to Python in the sense that you can write F sharp scripts and evaluate the F sharp scripts and get immediate feedback that you get from dynamic language. But on the flip side, you can also compile it like .NET, like the regular ASP.NET, you say .NET Build, .NET Run, .NET, all of that stuff.
That makes sense.
So it has that flexibility. So you see that because of the hereditary of where F sharp came from, scientists use it a lot, right? Some of the companies I worked with that use F sharp were mostly bioinformatics, biosciences, and things like that. And they used the fact that it's a very scripty-like language to do quick exploration of data, to analyze data, to generate, similar to like Jupyter notebooks with Python and so on and so forth. But when all the models and when all the logic is solidified, you can then copy that same code into a real application, build it into a DLL, ship it with a NuGet package, everything.
Well, is that not stressful? So start moving the codes, and that's stressful.
No, it's better than rewriting it, because what those people were doing before was they would do the exploration in Python and then they will now rewrite it in C++.
Okay.
Right? So, but with F sharp, you don't need to do that rewrite. You can just take the code exactly and just deploy it. And it's very fast.
Okay. Yeah. So what kind of application can we build with F sharp?
Excellent question. So maybe I should share my screen.
Okay.
I don't know whether I should. Okay, let me first share my screen and explain all the different kinds of applications you can build.
All right.
Or better yet, never mind.
Okay, but you will still share your screen anyway.
Okay, I'll still share my screen anyway. So
Yeah.
you can use F# to build anything, right? You
Okay.
can use it to build machine learning applications. You can use it to build ML models. You can use it to build web applications. It runs on ASP.NET Core. It even has support for entity framework.
Wow.
You can use it to build actor system, right? Distributed systems. So distributed systems here are, imagine you want to run a piece of computation across 100 servers at the same time. You would use some kind of framework like Akka.net, for example, to do that. So people who do high velocity trading, right? Stock trading, people who build financial solutions, they use F# a lot because it is more suited towards those kinds of high computation applications. You can also use F# to build web apps as well. So you can use it to build front-end apps with React as well. So F# has a compiler called Fable. And what Fable does is it carries your F# code and spits out JavaScript for you.
Really?
And then you can interpret. Yes, you can interpret with your React and write out all your React stuff and build out the UI. So, for example, when I was at Edelweiss Data, we essentially built the entire platform with F#. When I say entire platform, I mean 100%. So the front end was F#, the back end was F#, even down to the database plugins we had were all in F#.
Wow.
So, yeah.
So why are people not using F#? It's really amazing, to be honest.
Yes. So people aren't really using it because it's not familiar, right? So if you think about the languages that have been successful, most of them are C-like languages because developers don't really want to switch over to something that is going to essentially break their brain initially. But the thing is that now we are seeing a lot of F# uptake because many languages are now starting to borrow all these functional paradigms. So it's now becoming even more and more familiar, right? Even to the point where things like inline constructors in C# and so on and so forth. All those things mimic F# syntax. So for example, async await actually was developed by F#, right? And I can show you what that looks like. So F# was the language to transform these kind of logic of, instead of adding callback everywhere, to now make it look sequential. So you can now have like, after this, do this, after this, do this, after do this, right? That is a built-in functionality in the language called a computation expression. But the point is that was implemented first in F#, and then C# borrowed it, and then Java borrowed it, and then everybody in the
borrowed it. But I would like to see. I would like to see how it looks like. Maybe when you share your screen, you'll show us that.
Yes. Correct.
Okay, so right. I was going to ask the companies that use F#, but you've mentioned few, which you've worked with, which is your personal experience. Do you know of any other companies that use F# language?
Yes, so there are many. There are most of the companies that use F# are European companies. And I think that kind of helps Nigerians in particular, because when you're trying to get foreign jobs, right, you are likely to get jobs in the same time zone as you. So we're talking companies in Germany, companies in the UK, and so on and so forth. Those are the companies that mostly use F#. So F# is something that is good to learn. In fact, my first foreign gig was in F#. But aside from that, in terms of commercial success, there is this company called Jet.com, right? I think they were bought over by Walmart. It was a startup that became a unicorn very quickly. They were trying to compete with Amazon, and it was all written in F#. So they used, they had this thing of price matching or something like that. They had like a very clever pricing algorithm that was written in F# that they were using to compete, and they got bought over by, I think, Walmart or so. So that's one of an example of a successful company that ran with F#, that used F#.
So earlier you mentioned that F#, we can make use of F# when building machine learning and other applications like that. Yeah. So I want to ask, do you think F# is really like working in the modern technologies like AI, cloud services, and other .NET technologies?
Yes. So if you look at fslab.com, So fslab.org is a set of data science packages, data science libraries, all written in F Sharp. So you can use them to create your own ML models, whether it's clustering models or neural networks or things like that. You can use F Sharp to do it. Unfortunately, Python has kind of grabbed, the entire industry. But then there are still interoperable packages you can use to talk to use like Python in your F Sharp coding.
Okay.
In terms of performance, F Sharp is orders of magnitude faster than Python.
Okay.
Because it's running on .NET and it gets compiled and JIT and all of that stuff. But yeah, you can use this thing. And also, I think Microsoft has ML.NET as well. So with ML.NET, you can use F Sharp to interact with those libraries and build whatever machine learning tools or solutions that you choose.
All right. So since we're talking about the fundamentals of F Sharp, and it's more like, this topic is more like a topic for beginners. So if you want to give someone who is starting out, you want to tell them some key concepts of F Sharp, what would they be?
Yeah, so the key concepts in F Sharp is, so before I continue, one thing I really love about the language is that the language tries to be as derivative as possible. I don't know if that makes any sense, what I just said. So essentially what the language does is it pillars as few pillars as possible, so that once you learn those pillars, all the other knowledge is built on top of those pillars. Okay. And I'm going to tell you what those pillars are. The pillars are, I think I have it here. You have your lead binding. You have your functions. You have your loops. You have pattern matching, discriminated unions, collections, and computation expression. And I think that covers 90% of the language, right? These 8 things I just mentioned. So again, F Sharp seems daunting because it's unfamiliar. But if you learn it, if you learn these 8 things, these 8 basics, you will know how to use the language and you'll be able to get very productive. Something else I didn't mention as well is that F Sharp is a very pragmatic language. In fact, it is the most pragmatic language I've ever seen. What does that mean? It means that it is not about architecture and code and craziness and complexity. It tries to get to the heart of whatever it is you're trying to do. You want to extract data straight to the point. You want to create a web server straight to the point. In fact, something like a minimal API, right? So you have a C# minimal API. It was inspired by F Sharp.
Okay.
So you want to create an endpoint. Your endpoint is just a function. That's it. Just a function. It takes an input, spits out an output. That's it.
Simple.
No need for complex dependency injection and all those craziness, right? Yeah. I will even show you a demo of what I'm talking about.
So, can you just walk us through the basic syntax of what you just mentioned? And don't forget the async and await. I really want to see that.
Yes.
Okay, you can just share your screen and just show us.
Absolutely. So let me share my screen.
All right, sir. And again, before when you're on that, I'm curious about this. So can we say F Sharp is an OOP?
Okay, that's a very good question. The answer is yes and no. F Sharp is multi-paradigm, meaning that F Sharp also supports OOP as well. So you still have your objects, your classes, your inheritance, your interfaces, and things like that. And it's not even a case of, it's a functional language, don't write OOP. No, OOP is part of F Sharp. In particular, F Sharp's flavor of OOP is called object programming. It's different from object-oriented programming.
Okay.
So with object programming, you still create your classes, you still create your objects, but you don't model your program around object. You model it around functions. So it's a functional multi-paradigm language. So you can do OOP.
So which means we don't have to instantiate our class, like we don't have to instantiate our to get No. I get that. No. All right. You can just go ahead to show us. Let's see the almighty F Sharp.
All right. Yeah. Let me can you see my screen?
Not yet. Okay, it's coming up.
Okay. So
all right.
Great. So now I hope it's clear. Can you see it clearly?
Yes, it is.
Okay. Yes. Now the beauty of F Sharp is All you need is just to install. You just need to install. You only need
Okay, can you zoom in or just increase the thing to
content.
maybe 100? Yeah, it's cool.
Okay. So the thing with F# is that you don't even need to install anything, right? All you just need to do is just install your .NET SDK and you are good to go. If you're using VS Code, you now need to install something called, there's an extension called Ionide, right? I'll need to find it. Just install the Ionide extension, install your .NET SDK, you're ready to go. And you can actually just run your F# straight away using something called F# Interactive, or aka FSI. So right now on your system, if you do .NET FSI, you're already writing F#. That's simple. Right? Remember what I told you? Straight to the point.
Straight to the point.
Straight to the point.
So the extension is .fx. FXX was
FSX stands for F# script. FS is F# file, right? So your F# file is what you compile into your DLLs, your binaries, and so on and so forth. Your FSX is just a script file you can just execute straight away. Like Python.
All right, you can go ahead. Thank you.
Excellent. So again, you have your .NET right now, .NET FSI, you're already in F#, very simple. And the first thing you can do is to say, let A equal to 10. Okay? And immediately it tells you that A is 10. Okay? Now this is where, believe it or not, I know this doesn't look fancy, but this is where F# starts to deviate from every other language, because we were, if you think about how you learned programming, when you are starting out, is when you saw this, you thought this was a mathematical equation, correct? And someone had to beat it into your brain that no, this is assignment, right? So you are assigning 10 into the storage location A, correct?
Yes.
Now, F# is disabusing you of that mindset. It's telling you, no. What it originally was is what it is. So when you do this in F#, you are saying that A and 10 are the same thing. It's not an assignment. You're not assigning a variable to a variable location and all of that stuff. These are things we had to learn as part of C, as part of this whole C language of family of languages. So for example, so if we wanted to do assignment, we need a separate operator called, say, let mutable A equal to 10. Okay, I think you need double semicolon, sorry. Let me do it again. Sorry. So let's do .NET FSI. So we said let A equal to 10. Double semicolon is how you tell the FSI to run the expression. Okay. Now, if I wanted it to be mutable, I would say let mutable B equal to 10. Now, if I want to assign B, I would do this instead. B is assigned 11. So you can see these are two different things. Okay. This one is doing something called a binding. A binding is saying I take a variable name and I'm binding it to a value. That's a binding. Okay. Whereas a mutable binding, aka a variable. So the first one is a value, the second one is a variable. A variable is something that can change as the program goes along. Yes. These are the things you want to avoid in programs, because these are the things that will require you to need a debugger. With a binding, you don't need a debugger, because A is always going to be 10, regardless of how the program is written. So I can go through the entire program and replace all the A with 10, 10, 10, 10, 10, and the program will remain the same. Okay. All right.
Understood. So the B less than minus, I thought it's less than minus. So you called it something. The B.
Yes.
You said B is B. What do you call that sign?
This is called the assignment operator. So you are assigning 11 to B. You are doing what we do in C# and all that .NET languages, where we're assigning a variable, right? It's different from
but this one is different.
Yes.
This one is different. Okay.
So you can assign a variable, but you can also bind a variable, but you can also assign a variable, and they're two different things. And the reason why that is important is because you can have situations like this. Let's say I have B, C equal to 10, 12. Now, if this was assignment, this would start to scatter your brain, right? But it's not assignment, it's binding. So you are binding B to 10, you are binding C to 12. And indeed, if I run this, so the way you run it is you hold Alt Enter, you highlight a code, Alt Enter, it just runs it immediately in FSI, and you see the outcome immediately.
So 8, 10, okay.
Okay.
Yeah.
So this is binding. Now, I told you there are pillars. Binding is one of them. And then those pillars can be used to build on to get more and more complicated understanding. So for example, let's say I want to create a function. A function is just a binding. Remember, I told you in F#, a functional language, a function and a value are one and the same. Like they are not necessarily interchangeable, but they can be thought of as interchangeable. So for example, if I want to create a sum function, right? I say sum A equals to A plus 2. Let me say double. Let's create a double function. Double A is A times 2. Okay. Now, the first thing you notice is that there is this strange syntax here, this int to int. And believe it or not, this is a full-blown function in F#. Okay. Straight to the point. No functions or blah, blah, blah. Straight to the point. And how do you run this function? Well, you just say double stick, double 5. You run that, you get 10.
Double 5. So if I want to test, let's say, let int this, so it will be int 5, or you can just assign any number, what's called any number to it.
Yeah. So first of all, yes, any integer to it. Now, one thing you also notice as well is I never specified any types anywhere. Right? I didn't say that something is a string, something is an int. That's because in F# has a type inference. Type inference here refers to the idea that you don't need to specify the type. The compiler can infer what the type is. So for example, here it knows that A is an integer. But if I did 10.2, then it now knows that A is a float.
A is a float.
Okay? If I wanted it to be decimal, I'll say M, and it now knows that A is a decimal. Okay?
I get that. Yeah.
Yes. So like I talked about functions, these are examples of functions. You can create a function, call it double 5, and let me go ahead and run this. Use Alt Enter here. Let's see 10, and I can do 15, for example. Run this and get 30. Okay.
30.
Yes. So these are functions in F#. Now, the next thing we are going to look at is I talked about loops. How are loops done in F#? Okay. So let's take something simple. Say, for example, I want to create a for loop. So I'll say for I in, and I create a sequence. So I can create a list here to say 1, 2, 3, 4, 5, for example. Okay. This, you know what? Maybe before I even explain this, let me explain what sequence is. Let me explain all the data types in F#. So you have your strings, you have your doubles, you have your ints, but you can also have your list. So if I, for example, if I can say int list is equal to 1, semicolon 2, semicolon 3, semicolon 4, semicolon 5. Okay. So this is a list of 5 ints. You run that, you have this here. Now, semicolon has a special meaning in F#, right? It's a way to delimit value, but it also could mean empty lines. So F# is white space sensitive, similar to Python. Okay. So you can have something like this. And let me create white space. And you can remove the semicolons at the back. Okay. So these two are the same thing. All right. If you don't want to write things in new lines, you can just put a semicolon between them and collapse it like we did before. Okay.
Okay.
All right. So now going back, we now have a list of ints like the. You can also have an array. So if I want an array, int array, I would have it like this: 1, 2, 3, 4. Right? You can also have a range. So So we say an int range. So a range is similar to an array, but you can say 1 to 3 or 1 to 20 instead of typing it one by one like this.
I'm familiar with this one.
Yeah, exactly. then you can also have a negative ranges. So you can say from 20 to 1 to 20, count down to 1, right? And be reducing 1 each way. So if you run this, you get 20 to 1. So this is reverse of it. All right. Now, these are, so now, okay, I've explained these structures. You can also have your object, your struct. In F# we call them record. For example, we can have a record like this, and I can specify that this record has, using record. Let me say there is a person record. That's a person, and it has a first name, which is a string. It has a last name, which is also a string, okay? Like this, right? And now I can create a new person. So I can say OD is equal to, and I don't need to specify person again. I can if I want. So I can say person dot first name equal to OD, and person dot last name equal to Babu. So I could do it this way, or I could just remove this altogether, and the F# compiler can infer that, okay, you have first name, last name, you're definitely talking about the person here.
Right?
So if you look
this
at
looks like JavaScript, kind of.
Exactly.
This part.
This syntax looks like TypeScript because TypeScript took it from F#.
Oh, okay.
Yes.
I can see it now.
You can see it now. Yes. So you can have your records and so on and so forth. To be fair, right? F#, this syntax is not really from F#, because remember I told you F# came from its own line of languages. So there are a bunch of languages. I think Haskell is the exception. So OCaml is exactly like this. Standard ML looks exactly like this. So none of these knowledge is new per se. It's just that F# brings everything together in a cohesive unit. Does that make sense?
Okay. Yes, sir.
Okay.
It does.
Okay. Yes. So you can have a person here, and by default, F# has this thing where it has something called structural equality. So structural equality is if the contents of a struct and the contents of another struct are the same, you can just say, are they equal? And then they will match. It's not like C#.NET that has object equality, where you can create an object. They may have the same properties and everything, but if they don't have the same pointers or the same reference, then the equality won't work. So behind the scenes, the F# language is doing a lot of gymnastics to make the .NET syntax, because the way .NET is reference equality by default. So to make that .NET syntax work with the functional style, okay? So these are records like I've talked about, and you can run them and you can see what the record is like. So for example, if I came here and I say OD, did I
say the value
of
the constructor is not defined?
Yeah. I think it will work now. So you can see it's a person, first name, last name, and so on and so forth. Okay. Now, I've talked about records. Now, this is where it gets interesting, and I want you to pay attention here. So F# has a concept called discriminated union, right? I've explained tuples. Tuples are simple. Tuples are just collections of values. You are familiar with these, I assume. So you can have a tuple. Tuple will be equal to, say, 1 and ONE, okay? Like this. So this is a tuple.
Yes.
All right. Now, F# has something called a discriminated union. Now, let me explain. This is the second pillar sort of I'm getting into. So with discriminated union, you can have a type and say this type is fruit. Okay. And there are 3 kinds of fruit. There are mango, there is orange, and there is banana. Like this. Now, what this means is that fruit here is like You can think of it like an abstract class, and then you can think of each of these as inheriting from that abstract class, right? The difference here is that the F# compiler ensures that this type is sealed. So think
Is
about
what?
is sealed. So
Okay.
if you think of let's go back to the OOP idea, because are you familiar with
Okay.
you're familiar with OOP, correct?
OOP, yes, yes.
So in OOP, you create an abstract class. Now, when you create that abstract class, you don't know how many classes are going to subclass that your abstract class. The classes that subclass it could be 50, 100, right? That is dynamic. It's only known at runtime. Now, if someone handed you a fruit, how would you know which fruit it is? There's no way to know, right? Because the abstract class will hide all that implementation, which is what OOP was designed to do. Now, it gets interesting with F# and functional languages in general with discriminated unions, because here the compiler enforces that if you pass me a fruit, it must be one of these three. You can't subclass it. That's what I mean by sealed. You can't subclass it and extend functionality to it, right? So that way it does something called exhaustive checking. So exhaustive checking is, if you give it a fruit, it will check every single case to make sure that it is correct every time. And if it's not correct, you get a compiler error. Does that make sense?
Okay. Yeah.
So for example, let's say I wanted to print fruit, right? Like this. And I now have my fruit here, which is a fruit. And I came here and I said something like, okay, so I now have my fruit here. I will now match fruit with mango, and I will now say print fn mango. Okay, and then if you notice, I'm getting a squiggly already, because it's like, hey, it's incomplete. You've not covered banana. So let me go ahead and cover that. I'll say banana goes to print fn banana, and finally to say I need to cover orange. Okay, so say orange, print fn orange. Okay, so now that I have this, now you see the compiler is now happy. What this means is that if I were to create a fruit, if I were to say my fruit equal to banana, like this. Okay. Oops, I think I needed to execute these. Let me just execute everything. So if I create a fruit called banana, I can come here and say print fruit banana, and it will print it correctly. Now, we deploy the app, we launch it, the app goes live, everybody is happy. And all of a sudden, the program manager comes and says, you did not add pineapple. There's supposed to be pineapple in this thing. Now, if you come here and add pineapple, all of a sudden, everywhere in your code where you've added pineapple will now flag a compiler warning to say, you haven't captured the case of pineapple. These are subtle things that cause bugs in programs, right? Where requirements change, you make changes to the program, you've broken something without realizing you've broken something. And it's only when you deploy it that you now find out that, oh, we forgot to handle pineapple, and all of a sudden everybody's scrambling to ship a bug fix. Here, the compiler can just catch that for you. So let's go ahead and add it.
So instead of adding it this way, is there like following solid principle? Can we do that here, where we can just kind of like maybe make use of, instead of like changing the code, maybe like, although this is kind of different, like maybe we can just inherit from a base class or something to expand it instead of adding it, like changing it.
Yes. So again, to answer your question, yes, it's possible. Yes, I could write it that way. I can still write my abstract class. I can still inherit from it. All of that is still there. But this is an extra layer that doesn't exist in other languages. Now, why does this layer exist? It exists for data in particular, right? Data comes in different shape, and your program needs to be able to handle those shapes. What tends to cause bugs is when the shape of the data changes and all of a sudden somewhere somebody is trying to dot into something that is null. All of a sudden you get null reference, etc. Right? So having discriminated unions helps prevent those cases, because it will prevent whenever the shape of the data changes, the rest of the program knows that this data has changed shape. Now, the thing you talked about of inheritance and all of that stuff, that goes into that is useful for behavior, not data. Right? So it's if, for example, you want to be able to swap behavior easily, then you should have your abstract class, inherit from your abstract class, and so on. In fact, let me just go ahead and just show you what that looks like. So say, for example, I have my interface. I can say root printer or whatever, right? Equal to, and I say abstract member, say print fruit, something like this, right? And it takes a fruit. I think I got this wrong. Sorry, hold on. It takes a fruit and returns unit. So unit here. So what unit is? Unit is the equivalent of void. So if something returns void, it returns unit in F#. And the reason for it is that every function in F# has to return something. So this is like saying, so if you notice, this is saying fruit to unit. I mean, I take a unit, I take a fruit, and I don't return anything back. So that's what I'm doing here. So now I can now create my abstract implementation of function printer. So F# has a very nifty OOP feature. So you can even create objects on the fly using something called an object expression. So I can say fruit, I can say my custom fruit printer equal to new fruit printer with member print. Let me write well so that it doesn't look crazy. Let me do it this way. With member print fruit equal to print fruit, like this. No, I think I need to write it in full. Oh, I forgot something.
The P is capital.
Yeah, no. This is what's supposed to look like. So this right here is an implementation. So this is the abstract class or interface. See? Okay. And then this is the implementation of it. You can create, it's an object that implements this straight away. So with this, I can now come here and now say my custom fruit printer dot print fruit. And then I specify the name of the fruit, say banana, like this. So let's run the whole thing. You can see that it printed banana.
All right. So because of time,
yes.
Can you show me the async, because we have to see that?
Yeah. Yes. So I was explaining something about computation expressions. So F# has this concept of computation expression. I'll explain what that is. It's a way for writing. It's a way to write programs that have specific syntax behavior. So it has custom syntax. So I can show you what that looks like. So say, for example, I want something to run in an async fashion. So I will say get number async, right? And now I will just type async here. Okay, I will say async, which starts the computation, and then inside I can now put my expression here. A nifty way to think of this is think about the link syntax in C#, right? You know about the link syntax where you say from this in this and so on and so forth. So that link syntax, right, is a computation expression. In other words, it's a language inside the language, if that makes any sense. You have your regular C# and so on and so forth. Then when it gets to the link, you can now write workflows, quick workflows, or okay, do it like this, write this SQL query and execute.
Yes.
So the same thing applies to F# as well. So you can have small islands of computation you write. So for example, if I'm going to pull data from the web, so let me just give me a few seconds. Let me try and then hold on. Give me one sec.
Okay.
Okay. I'm just going to just copy the code so that I don't have to type it from scratch. But let's take something simple.
Okay.
Say for example, I want to pull data from 3 different URLs, one from Microsoft, one from I think one from MSD and one from Bing, and I want to do it in an asynchronous fashion, right? Then you can now create your async expression here, and you can now write your code inside. Now, here's where it gets interesting. Now, when I have a task, an async task, I have to await it as, so this is a .NET task. I have to convert it to an F# async. That's what this is doing. But after the conversion, you now have this let bang. So what this let bang is doing is essentially doing what your await will do. It will unwrap the async object and extract the contents and give it to you, which is what async await does. Okay. So for example, you can now have, let me just go ahead and run this so you can see what that looks like. I run it like this. And now you can see that, okay, let me take it one more time. So this was quite fast. Remember, my network is too fast, but you can see that it was able to do it in parallel. Now, to prove to you that this async you're looking at here is not built into the compiler. This async is just a library, and you can create your own library. So for example, when I was working at Edelweiss, we had our own validation library. So the validation library is going to say, execute a line of code, go and validate if it's successful or not. If it's successful, come back, continue the next line of code, go and validate if it's successful. If it's successful, come back and do all of that stuff. So you can write some workflows. It's not built into the compiler, right? For example, there is a sequence workflow for IEnumerables. Say, for example, I want to have a sequence of numbers. So I can say numbers equal to sequence. And say, for example, I have 1 to 100, right? So here I can, so, okay, good. So let's say I have a list, numbers here, 1 to 100, like this.
Okay.
Now, if I want to yield from that, oh no, sorry, let me change the idea. So say, for example, I have a for loop. So I say, or better, let me use a while loop. Say, let's say I say while true, right?
Okay.
And then I create a mutable variable here, mutable, I equal to 100. Let me start with 1, right? And then I assign I to I plus 1, I to I plus 1. I think this is all familiar, correct?
Yeah. But of course, the F# sign is not familiar.
Okay.
The arrow, that's...
Yeah, this arrow is this thing. Okay. The arrow is assignment, like I said. So now I will now say yield I. Okay. So if you look at this may look like it's never going to stop, but it actually does stop. And you will see why in a moment. Because it's a lazy sequence. Right? So it's only going to run 2, 3, 4, 5 and just stop because it's lazy. Okay.
Okay.
These lazy sequences, you can in F#, this sequence is also a computation expression similar to async here. And it allows you to have sequences inside of, like, it allows you to write looping kind of structures similar to LINQ in a way inside of the sequence. So say, for example, I wanted to first print 100 numbers before I started counting, right? So I could say I could say numbers. I can just redefine it. 1 to 100. Okay. Now, if I come here and I yield this, see what's going to happen. This won't even work. I can now use yield band. So this is kind of like a thread syntax. So what this is saying is extract each number from these numbers 1 to 100, and then be printing it as part of this your sequence of print. This your printing sequence. So if I were to run this, you'll do something like this. And if I were to say sequence.take 1000, they just want the first 1000 numbers. If I run this, oops, let me go ahead and do it here. Hold on. Let me.
All right.
List of C. Or better yet, I can just say list of C numbers and run this like this, and now you can see all the numbers here.
Yeah.
Okay.
All right. Thank you.
Yes. So
okay.
That was
wow.
I know this was a lot.
It looks, to be honest, it looks like I don't even know. Although I was able to relate to most of it because I understand, of course, I understand how programming works.
Yeah.
So and that helps me. But to be honest, I have to look into this. Can you share us a source if you have any resource that we can use to at least start? Because now I'll say I'm a beginner now. I'm a beginner also in F Sharp. So so I need to know if you have maybe a GitHub repo for starters. You can just share the link with us. Or if you have a resource, maybe YouTube or something, you can just share it with us so we can look into it.
Yes, you can. Can you share my screen? So can you share my screen so I can explain? I can show you all of them. So the first one is, if you're into data science, you go to FS Lab. You have a lot of stuff here. There is the F Sharp Software Foundation, which has all the tools, all the guides, right? All the kind of apps, data science, enterprise, mobile, web, and things like that. You can also go to there's a Microsoft F Sharp.
Oh, documentation, right?
Yes.
Oh, okay. Okay, that's fair.
All
right, thank you.
Hold on. I'm looking for something. Here we go. Sorry. So yeah, this is a good place to start.
Okay.
With F Sharp, you can see all the things we talked about, how to create thread binding, how to write your loops, and things like that. There is also a F Sharp for beginners introductory course here. It's 12 videos. So if you have time, you can just check it out and learn the language. I think you stand to gain a lot from it.
All right. Thank you, sir.
Yeah.
Thank you so much for joining Thank you, sir. Thank you so much for joining because I understand and I know the time difference. So thank you for taking our time to join the call. We really appreciate and we would like to bring you back to come and show us the deep part of this F Sharp. All right. Thank you so much.
Great. Thank you.
That was insightful.
Yes.
Yeah. So do you have any social media that maybe our viewers can join, and probably if they want to talk to you, if they can, you can just share with us, maybe Twitter or I don't know, or LinkedIn.
Yeah, so my handle is Oditrice. You can check it on YouTube, on Twitter, on LinkedIn. I don't know if it works on LinkedIn, but I can put the link in the description in below. But
okay,
yes,
you're on YouTube.
Yeah, I'm on YouTube.
You're on YouTube. Oh, okay, that's fair.
YouTube. So youtube.com/Oditrice.
Yeah.
You can reach out to me. That's where I have my channel. I even have some extra tutorials there as well as other.
I was asking about your YouTube, but you didn't talk about that.
Oh,
you didn't talk about that. Yes.
Yeah.
You didn't say that. Oh, okay.
So
that's fair. I think you can just share the link with us so we can attach it to this video when we post.
Yes, definitely.
Okay.
I'll share all my social media. You can reach out to me on X or Twitter, Instagram, and so on and so forth. And it's fine.
All right. Thank you, sir. Thank you.
Thank
all
you
right. We have a whole lot of things that we need to study. And thank you for joining. Thank you for viewing our channel. For more detailed coding like this, you can follow us and on our socials, and you can also subscribe to our YouTube channel, like and share with your friends. Until we see and meet again. Bye.